All right, so let's talk about solving trig equations with good ratios, meaning we can probably do them without a calculator. All right, so this first one, it says solve for theta in radians. All right, so first step always is we're going to try to isolate the trig expression. So I'm going to divide both sides by 2. All right, so start off nice and easy with our example that we use a lot, the sine of theta equals 1/2. Now, a lot of times it'll give us a range of values that we want for theta. Like theta has to be in between 2 pi or 0. All right, but that's not the case here, which means we have to find all the angles that satisfy this. Now, if we think of the graph of sine, and when we do these, thinking of the graphs helps us understand how many ratios we have to find. All right, this will, like y equals the sine of x, will look like this. We'll go in between 1 and -1. All right, and that would be 1 period. And if we were to graph the other side of the equation, like y equals 1/2, that would look like this. And we see that for every period, it's going to intersect this graph twice. And then if we were to keep graphing, like let's say we went in this direction, right, and that was another period, like -2 pi, right, every time you graph another period, it's going to intersect this line another 2 times. So every period is going to intersect this graph twice. So we're going to have 2 answers per period, which means there's an infinite amount of answers, but we can express these answers in 2 different ways. We could figure out, so if I were to do another one here, oops. All right, something like that. And that could be like 4 pi. All right, and it intersects here and here again. We could find what this x value is right here, which we know is pi over 6, because I know that the sine of pi over 6 is equal to 1/2, all right, because that's 30 degrees. All right, that answer is going to repeat every period, right? Whether I add a period, so if I add 2 pi, then I'll be here at my next point, which would be pi over 6 plus 2 pi, which is like 13 pi over 6. Or if I subtracted pi, it would also land on a point. So like every other point is going to be a period distance away from each other on the x-axis, so 2 pi away. So since this is the sine of just theta, I know the period is 2 pi over b, which is 2 pi. So one of my answers is going to be theta equals pi over 6, which is the angle that I got in between 0 and 2 pi, plus a full period, which would be 2 pi, all right, times k. And I'm going to make k an integer. K is an integer. And what that does is it makes sure that k is like a whole number, like 1, 2, 3, or -1, 2, and 3. So we can add a full period to our answer. All right. So if I were to sketch this out again, and just make a graph, like a bunch of sines. All right, so these are a bunch of sine graphs. All right, a bunch of periods. All right, and this is y equals 1/2 x. All right, if this is pi over 6, then when I add 2 pi, I would be at this interval, this intersection. If I add 2 pi, I'd be here. If I add 2 pi, I'll be here. And that keeps going forever. So as long as you add like a full integer of 2 pi, so like a full factor of 2 pi, you got your answer. All right. Now the other answers would be at these other intersections, here and here and here and here. All right, so that's the other angle between 0 and 360, where the sine of theta equals 1/2. Because remember, we're solving the sine of theta equals 1 over 2. All right, so theta could also equal 5 pi over 6, because that's 150 degrees. So the other positive angle between 0 and 2 pi, that when you take the sine of, you get 1/2. And then we'll also add 2 pi k. So we're going to add a period where k is again an integer. So what that means is, like, let's say k is 5. Well, then you got 5 pi over 6 plus 5 times 2 pi. So plus 2 pi plus 4 pi plus 6 pi plus 8 pi plus 10 pi. That would give us this point right here. Right? So they always repeat. That's what it means to be periodic. All right. So you're always just going to find your angles between 0 and 2 pi, and then add the period times k. And that's the strategy that we're going to use. All right. So those are our two answers on the bottom. Theta equals pi over 6 plus 2 pi k. Theta equals 5 pi over 6 plus 2 pi k, where k is an integer. All right. So that was a lot of talking to set up these next ones. So now let's try this. Oops. If you have any questions, let me know. So our first thing we're going to do is isolate the cosine of 2 theta plus pi over 3. So I'm going to add root 3 on both sides and then divide by 2. All right? And I get the cosine of 2 theta plus pi over 3 is equal to root 3 over 2. So now, instead of thinking of, so let's make our life easier for a second and break this up into two smaller problems. Let's let x equal 2 theta plus pi over 3 for a second. All right, and let's just find, we'll substitute that in. And let's just find all the angles between 0 and 360. I always mess that up. Or we'll go 2 pi. That make this true. So what angles between 0 and 2 pi would satisfy this? All right, and then we'll figure out what it is in terms of theta. That would be, x could be 30 degrees, because the cosine of 30 is root 3 over 2, or in radians would be 30 degrees pi over 6. All right, or it could be an angle in quadrant 4. So if we're finding the angles between 0 and 2 pi, we want to add, not subtract, and we would get 330 degrees, which in radians would be 11 pi over 6. All right, so now we know that we need, in order for this to be true, we need this to be, so 2 pi plus, 2 theta plus pi over 3 should equal pi over 6 or 11 pi over 6. All right, now that would be two of our answers, but there's really an infinite amount of answers. Now, if we think about the graph of, so I'm going to erase everything for a second. If you need it back up later, just tell me. I can always go back. All right. If we think of the graph of the cosine of 2 theta plus pi over 3, and then also the graph of root 3 over 2. All right, so root 3 over 2, that's approximately like 0.8. All right, and I'll tell you why that makes sense in a second. All right, so first let's think of the graph of the left side. So like y equals the cosine of 2 theta plus pi over 3. All right, I'm going to graph that in blue. So that we don't have to be super detailed with our graph, but we know a couple things. We know it's going to go in between 1 and -1, because the midline is 0 and the amplitude is 1. And it's going to start at whatever makes what's inside the parentheses equal to 0. So it's going to start at theta is equal to, or 2 theta equals negative pi over 3. And then you could divide by 2 and you get theta equals negative pi over 6. So it's going to start right around here. And it's going to start right there. And it's going to look like this. All right, but what would the period be? So the period is always equal to 2 pi over b. So in this case, b is equal to 2, because that's the number in front of x, or theta. So the period is pi. So if you add pi to negative pi over 6, you get 5 pi over 6. All right, so if someone entering, I'm going to add them. Don't worry, I'll put that back. All right, so on this interval, if we graphed the other side of the equation, so this, like y equals root 3 over 2, we can see on this interval between negative pi over 6 and 5 pi over 6, it's going to intersect the graph twice. And it's going to repeat every period. All right, it's going to repeat. So if we were to keep graphing the cosine graph, it would look like this. And like another period would be pi. So we added that to 5 pi over 6, right? Pi would be 6 pi over 6. So this would be 11 pi over 6. So there'd be another 2 intersections on this period here. So these answers repeat every pi units. So like this point is going to repeat every pi because that's a period. All right. And then same thing here in purple. These 2 points, they're going to repeat every period forever and ever because this cosine graph is just keep going up and down forever. All right. So if we could find these two solutions, all right, then we're just going to add pi times k, where k is an integer, because they repeat every period, and the period is pi. So we sort of already found that when we earlier, when we we figured out like which angles would you take the cosine of to get root 3 over 2. Remember, that was pi over 6 and 11 pi over 6. So in other words, we want 2 theta plus pi over 3 to equal pi over 6, and also 2 theta plus pi over 3 to equal 11 pi over 6. So to recap, we're not done yet, but we get the trig function alone, okay? Then you figure out what angles would you take the cosine of, ignoring this part for a second, to get this ratio, all right? And we got 2 angles between 0 and 360, or 2 pi. All right, then we're going to add the period times k to those angles. But first, we have to see what value of theta makes the input equal to pi over 6 or 11 pi over 6. So we have to solve both of these equations now. So if we subtract pi over 3 on both sides, right, that's equivalent to 2 pi over 6. And we get negative pi over 6. And then divide by 2. And we get negative pi over 12. So one of our final answers is going to be theta equals negative pi over 12 plus pi times k, where k is an integer. And I'll write it out, is an integer. All right, and then we do the same thing over on the right side, where we figure out what value of theta would make this equal to 11 pi over 6, because we know the cosine of 11 pi over 6 is root 3 over 2. So I'm going to figure that out by solving this. So subtract pi over 3 on both sides, which is equal to 2 pi over 6. So that's going to be 2 theta, is equal to 9 pi over 6, which reduces to 3 pi over 2. And then we could divide both sides by 2. And we get theta is equal to 3 pi over 4. All right, so our other answer would be, theta equals 3 pi over 4 plus pi times k, where again, k is an integer. So we solve the equation and then just add the period times k to it when there's an infinite amount of answers. And again, period is 2 pi over b for sine and cosine. pi over b for tangent. Now, let's check our answer real quick on a graph. So we have to remember that we got negative pi over 12 plus pi times k and 3 pi over 4 plus pi times k. So let's check this on a TI Inspire, which I closed out. That's a shame. All right, I look at your faces right now, see how confused or bored you are, but I wanted to record you, so I can't. But if you have any feelings or thoughts, you can talk to me right now while we wait for my calculator to load. And I'll try to address them in the next example. Should load up any second now. All right, so I'm going to open up a new graph, and now we're just checking our two answers that we got. All right, so add a graph, and if we look back at the original example, it was 2 cosine of 2 theta pi over 3 minus root 3. So 2 times the cosine. I'm going to do 2x, not 2 theta. The calculator won't know how to do theta. Plus pi over 3. Oops, plus pi over 3 minus root 3. And then minus the square root of 3. I want to see when that equals 0. So that looks right. Now, first we want to make sure that we're graphing in radians, and we are. Right, so that's good. Then we see if I do the analyze graph 0 tool, we can find one solution, which is negative 2.626, and then that solution is going to repeat like every period. So if I do analyze graph 0, like if I add pi to that, I'm going to end up right here. And if I subtract pi from that, so like minus pi times k, where k is negative 1, all right, I'm going to get this 0 right here. Now let's see if we were right. So if I do the scratch pad real quick, nope, don't want to do that. If I do scratch pad and I type in negative pi over 12 to see what that is as a decimal, that should give me the same answer. I get negative 2.617, which rounds up to negative 2.62, which is that answer right there. All right, and if you add pi to that, or any multiple of pi, so pi times 2, pi times 3, pi times any integer, right, you're going to get another point on that graph, 2.88. If I subtracted pi, I'd get negative 3.4. All right, so that answer checked out. And then the other answer that we got was 3 pi over 4 plus pi times k. So if I do analyze graph intersection, not intersection, because there's only one graph. So I want to see where it intersects with the x-axis, which would be a 0. All right, and I check out this point. All right, it's 2.36, which is 3 pi over 4. And then you could tell from the graph, it's going to repeat any period. So we just checked our work. So 2.356, which is 2.36, which is what we got here. All right, so this is what I mean by you could check it with a graph. You could just graph both sides of the original equation. All right, I didn't graph the right side. That was 0. I just used the x-axis. Right, and then I was able to check our work. So in conclusion, you're going to find your angles and just add the period times k every time. All right, that must have been a typo. All right, let's do 2 more. Unless they won't take as long. I think this is useful. All right, so this one. So we need to isolate the trig function. Now we have 2 different trig functions, but they're the same type of trig function. They're both the sine of x over 3 plus 2 pi. So if I could subtract the sine of x over 3 plus 2 pi on this side, and then subtract the sine of x over 3 plus 2 pi on this side. All right, so that would give us a 0 on the right side. Need more room. And on the left side, we would get 4 times the sine of x over 3 plus 2 pi, because those are like terms. They're both like the same term. It's just 5 minus 1 gives us a coefficient of 4. All right, and then we had that plus 2 here, which I'm just going to subtract it on both sides and get a minus 2 on the other side. And then divide by 4, and we get this is equal to negative 1/2. So I'm just going to erase everything and write it nicer. So the sine of x over 3 plus 2 pi is equal to negative 1/2. All right, so now I know that the sine of, if I'm doing this in radians, all right, this, well, in degrees, the sine of 210 and 330 would equal negative 1/2. All right, but I want that in radians, so I'll make that 7 pi over 6. All right, so in other words, we want x over 3 plus 2 pi to equal 7 pi over 6. All right, another valuable answer would be 330, or in radians, 11 pi over 6. So we also want x over 3 plus 2 pi to equal 11 pi over 6. Okay, so now we can figure out what values of x would give us those angles here that we could take the sine of. So we got to solve these equations. So if I solve this one over here, I can subtract 2 pi on both sides. So it'd be 7 pi over 6 minus 2 pi, which is 12 pi over 6. And we get x over 3 is equal to negative 5 pi over 6. And then if you multiply both sides by 3, you get x is equal to, right, you could just multiply this side by 3, and that cancels out. Multiply this side by 3, that becomes a 2. We get negative 5 pi over 2. All right, so that's one of our answers, negative 5 pi over 2. All right, but there's an infinite amount of them, so they're gonna repeat every period. So I know that this has a period of 2 pi divided by b, which is 1/3, which is the same thing as 2 pi times 3, which is 6 pi. All right, so this answer is going to repeat every period 6 pi, so every multiple of that period, 6 pi k, where k is an integer. So once we figure out our angle, there's always going to be like 1 or 2 for every period, or maybe 2 or 4 if it's like something squared. Then you just add the period times k, where k is an integer. Because if you think of the graph, that's how often it's going to repeat. So I'm going to write that down so I can make note of it later when I check our work. All right, I got to erase all this other stuff. All right, then we're going to solve this other equation here. I wish I could leave this on the board longer for you, but then I have nowhere to write. So I'll post this video later and you can just kind of like scroll through it and screenshot certain parts. All right, now if I solve this, all right, x over 3 plus 2 pi equals 11 pi over 6, I'm going to subtract 2 pi on both sides, which is 12 pi over 6. So I get x over 3 is equal to negative pi over 6, and then multiply both sides by 3, and I get negative pi over 2. All right, that's going to repeat every period. Remember, the period was 6 pi, so it's plus 6 pi k. All right, so that's our other answer, negative pi over 2 plus 6 pi k. All right, now let's check our work. So I'm going to graph. You could graph both sides, or you can graph one side and set it equal to 0. All right, it's always good to check your work so you know how you're doing. So I'm going to open up a new graph here. I'll zoom out so you can see it better. All right, so I can graph 5 times the sine of x over 3 plus 2 pi plus 2. Or you can solve any equation by graphing both sides and seeing where they intersect. And then also graph the sine of x over 3 plus 2 pi. Okay, so zoom out a little bit, see what's going on here. All right, just to understand what we're doing. All right, so if I were to draw on the screen for a second, like this, so we see like an intersection. So let's cut this off at like 1 period, like the distance between the minimums would be 1 period. All right, so every period you can see there's 2 intersections of both sides of the graph. And like if I were to color coordinate them, like these points kind of correspond, like they're like the first one of each period. All right, and they're going to repeat every period. So that was 6 pi. And these other points where the intersections are, they all kind of correspond to each other. All right, they're also a period away from each other on the x-axis. So if you just keep adding the period 6 pi, multiples of that, you'll get all those answers. All right, so remember we got negative pi over 2 and negative 5 pi over 2. And if we analyze the graph and look at the intersection here, all right, we get negative 1.57, which is well, not exactly, but that's half of 3.14. That's half of pi. So that's negative pi over 2. That's what this point is. All right, and if we analyze the graph here and find the intersection, all right, that's negative 7.85. All right, that's negative 5 pi over 2. All right, so a little bigger than 2 pi, which is 6.28. All right, and then if you added 6 pi to that, that would take you to this next point right here, because sine is periodic. So like these points will just keep repeating. Intersection, all right, here and here. All right, there's another point. All right, so that'd be 6 pi added to negative 5 pi over 2 to get that next point. Okay. So really it's taking a long time. Sorry to bore you on the last period of Friday. My bad. But this last one, just want to go over it because it involves secant and also something squared. So I won't go through checking it with a graph unless you want me to. But the way we're going to solve this is isolate secant squared. So subtract 3. All right. Then we get secant squared is equal to 2 pi over 5 minus pi. All right. Take the square root. So you get positive or negative root 2, because we took the square root, is equal to the secant of 2 pi over 5 minus pi. All right, which we can rewrite this as its reciprocal, oops, not tangent, cosine of 2 pi over 5 minus pi. Oh, where's the x? Oh, there's an x. I never wrote the x. My fault. That's very important, or else it doesn't make sense. All right, is equal to the reciprocal of that, which would be plus or minus 1 over root 2. And if you rationalize that, that's root 2 over 2. All right, so we know that all the angles between 0 and 360 that would satisfy this, if we plugged it in for 2 pi over 5x minus 5, not minus pi, all right, would be 45 degrees, which is pi over 4. All right, or since it's positive or negative, it could also be in quadrant 2, which is 3 pi over 4. All right, it could also be in quadrant 3, which is 5 pi over 4, or it could be in quadrant 4, where cosine's positive, because again, it's plus or minus root 2 over 2, which would be 7 pi over 4. All right, now instead of boring you and solving all 4 of these equations by hand, all right, let me show you, if you have a CAS, how you can then use the calculator to do this. So if you open up a new calculator, all right, And again, we want to know what values of x would make us take the secant of those four angles, 45, 135, 225, and 315, all as radians. So if you have a cast, you go menu, algebra, solve. You can type in this expression here inside the cosine, 2 pi times x divided by 5 minus pi. And we want to see what value of x would make that equal to pi over 4. And we're going to do comma x because we're solving for x. And you get 25 over 8. So that's one solution. All right, and then do the same thing for 3 pi over 4. And you get 35 pi over 8. And then do the same thing with 5 pi over 4, which is 225. All right, you get 45 over 8. All right, and then do it one more time for 7 pi over 4. And you get 55 pi over 8. All right, so as decimals, all right, this one would be, just so we could keep it in mind when we graph it, this would be 3.125. All right, and then that repeats every 10/8, so every 2.5. Or not 2.5, I can't add 10/8, 1.25, my fault. All right, so that's all those numbers as decimals. So then we would take each of those numbers and add it to the period. So like 25 over 8 plus the period, which secant is reciprocal of cosine, so that has a period of 2 pi over b. So if we do 2 pi over b, 2 times pi divided by b, which was 2 pi over 5, right, we get that the period is 5. So these values that we got, 25 over 8, 35 over 8, 45 over 8, 55 over 8, since we're looking for all the answers, you would add plus 5k to all of them. And that would give you all of the times these two sides intersect. So our final answers would be what I just said. I'm just going to write it out. So x, not theta, it says solve for theta, but it should say solve for x, is equal to 25 over 8 plus 5 times k. All right, because it's 5 radians, that's the period. And then 35 over 8 plus 5k, 45 over 8 plus 5k, and then 55 over 8 plus 5k. And then they just keep repeating. So that's probably the easiest way to express it. You could express this more simply because it repeats, if you notice, it repeats like every 1 point. If you add 1.25 or 10 over 8, or 10 over 8 reduces to 5 over 4, right? If we add 5/4, we get this number. If we add 5/4, we get that number. If we add 5/4, we get that number. And if we add 5/4 again, we'll be back to adding a full period. So another way you can express this, and this is only if you see it, the answer in green is fine, would be 25 over 8 plus 5 over 4k, where k is an integer, because then they end up repeating every 5/4, because it just happens that these intersections happen every exactly 1/4 of a period. But the answer in green is fine. All right, and if you graph both sides of this equation here, you would see that they would intersect at all these values. All right, so I'm going to end the recording, see where we're at. Oh, wait a minute. I wasn't even recording this whole time. That's because I did it on Zoom. I'm going to end the recording this way.